Okay, so here's the last bit coming to Wolfram alpha, and I think I wrote this wrong on the board, but I think I said it right but wrote it wrong. So we're going to take the sum twice the square root, and I have my j here. Remember the width of those rectangles was 2/10.
Yeah.
I'm doing 10 rectangles now, so 2/10, and I have to climb up the first rectangle, second rectangle, third rectangle, fourth rectangle. That's what that j is. And then again, the width of the rectangles, I have to multiply by the width of 2/10. So I get the length twice this times the width 2/10, and I'm just pretending the height of my cylinder is 1.
Yeah.
Do you understand that?
Yeah, the height of this, yeah.
The height of the cylinder is 1, so I'm not going to do it in general here. Okay, and I'm also pretending the radius is 1. So we're going to get a simple thing. So height's 1, radius is 1, 10 steps here. And when I put that into Wolfram alpha, that's what's up on the screen right now. It calculates it, and it says 3.03 is the volume with 10 steps. But now I can change it to 100 steps. Pretty easily.
Yep.
We do the sum, and we get 3.138.
Almost pi.
Almost pi, yeah. Interesting. Let's try 1,000 steps. .1414 with 1,000 steps. What do you think about that?
It's getting closer and closer to pi.
Okay, so if I have a cylinder with radius 1 and height 1, what would you think the volume should be?
Maybe pi.
Why?
Well, that's what we're converging on here.
Yeah? But earlier in the day you told me a volume formula for a cylinder.
Yeah, it's the area of the bottom circle times the height.
Okay, in this case, what's the area of the bottom circle?
It would be pi.
What's the height?
1.
So pi times 1 is?
Pi.
Pi. So this amazing complicated sum with this square root in it does actually seem to be converging to what we think the right volume should be. Let's try 10,000 steps. Can you imagine drawing in 10,000 rectangles?
Wow, that would take a long time.
Yeah, it would take a really long time. Let's see what happens.
Computing.
3.141589.
89. Closer and closer.
Yeah, that's 5 digits, right? Because if we rounded that to 5 digits, we get 3.14159.
Yeah.
So let's just do one more. 100,000. I don't even know if Wolfram alpha can do 100,000 steps for us. But let's just see. 100,000 rectangles.
That would take several lifetimes.
Added together to make a cylinder. And so while we're waiting, oh no, it said it wouldn't do it. Okay.
Too big.
Too big. But people didn't used to have Wolfram alpha.
Yeah.
And this is what people like Newton and Leibniz and other people figured out how to do via calculus. And found that this is exactly equal to pi, which is really surprising, right?
Yeah.
That's cool. This is kind of a fun way to see the power of math. All right, good work this morning, huh?